video, we mentioned about the golden ratio phi. So square root of 1 plus square root of 1 plus square root of 1 plus square root of 1 plus, and so on and so forth. So in today's video, we are going to consider something similar to phi, whereby this x is tend to 0 plus. Then, what is this limit?
Pause the video now if you wish to solve it. Keep watching the video once ready.
Before we consider this limit, let's look at some nested radical that produce some nice solution. Example, if u equals to 2, we say that u minus 2 equals to 0. Then if you multiply with u plus 1, then it is still equals to 0. But for left hand side, we have u squared minus u minus 2 equals to 0. Then u squared equals to 2 plus u. U therefore equals square root of 2 plus u. Notice that u itself is positive, then we only take the positive square root. Okay, now in this case, we can have something nice. We can have 2 plus u. U is equal to square root of 2 plus u. But for this u, it is actually equal to square root of 2 plus u. And u equals to square root of 2 plus u, and so on and so forth. We just know that u can be written in this manner. And since u is equal to 2, and therefore this is equal to 2. Based on this method, we observe there is an interesting pattern. We can do the similar method for any number that we want. Let's say we start with u equals to some p. U minus p will be equal to 0. Of course, you still have a 0. You have u squared minus u minus p minus 1 equals to 0. U squared equals to pp minus 1 plus u. So u will equal to square root of p minus 1 plus u. We will let q to be p minus 1. And this will be equal to q plus u, where u equals to square root of q plus u. And this process will go on. So it seems that we can use the similar method and to get any number that we want. Now, based on this method, we may have another interesting observation. If let's say p equals to 0, p minus 0 multiplied with p plus 0 minus 1, 0 minus 1, that is negative 1. You have this is actually u, and this is u minus 1. U squared equals to u, then u will be equal to square root of u if we take non-negative value of u. If we proceed this, then this will be u. U itself is square root of u. So this is square root of u. U is square root of u. U is square root of u, and so on and so forth. And we have this is the answer. So this means that u will equal to 0 in this case. On the other hand, if we are using this method again and let u equals to 1. So this will suggest that p equals to 1, so u minus 1. Multiply with u plus 1 minus 1, that is 0. Then you will have u squared minus u equals to 0. And from here, u squared equals to u equals to square root of u, and therefore equals to square root of square root of square root of u, and so on and so forth. And we start with u equals 1, and therefore this is u equals to 1. In this case, we just show that this expression equals 1. But previously, we showed that the same expression equals to 0. Definitely, there must be something wrong. It suggests that if we want to use this method, we have to see if there is any condition. So there are two ways of getting this answer. Number one, we use technology. Just simply use Excel and we define a1 equals square root of x, an plus 1 equals to square root of x plus an for n greater than equals to 1. By this definition, square root of x plus square root of x plus square root of x, this is therefore equals to a limit of an when n go to infinity. Suppose this is equals to L. The first method that we can use is by technology, by using Excel, that we can plug in the value that close to 0 and see what will happen. So when x equals to 0.1, L, we find out that it is equals to 1.091608. When x equals to 0.01, L equals to 1.009902. X equals to 0.001, L equals to 1.00000999. X equals to 0.0001, L equals to 1.0001. The second method, prove this mathematically. We suppose the limit exists and let it be equal to L. So L will be equal to this. Then this will equal to square root of x plus L. L squared is therefore equal to this. Then L squared minus L minus x equals to 0. From here, using the quadratic formula, we will have L is 1 plus minus of square root of 1 plus 4x over 2. Now note that x must be positive so that the expression is meaningful. And it means that L, it must be greater than or equal to 0. Note that 1 minus square root of 1 plus 4x over 2 will be a negative value for all x greater than 0. So therefore, L will be equal to 1 plus square root of 1 plus 4x over 2 for all x greater than 0. And L will be equals to 0 if x is equal to 0. This will equals to the limit of x tend to 0 positive 1 plus square root of 1 plus 4x over 2. And the answer is equals to 1. I hope you enjoyed it, and I hope that I convinced you that this is equals to 1 and not equals to 0. Thanks for watching.